I'm going to go through this question with you because it contains a little bit of maths and some good statistics. So before you start, you have to read through the entire question and you have to attempt all of the questions. So you should only be watching this video if you have read through the entire question, you know what the question is about, and you have tried to do it. Okay. So this question is about ploidy, which is how many copies of a single chromosome we have. We are diploid, meaning that we have 2 copies of chromosomes. This plant is tetraploidy, meaning it has 4 copies. So here is our table from the chi-squared test. As we know, a chi-squared test compares the difference between observed values and expected values. Okay, so that's what a chi-squared test does. The first thing they're asking us to do, take that out because that's actually the answer. The first thing it asks us to do is to calculate the expected number. So here's our expected column. So the expected number of plants that did not produce gametes and those that did produce 2N gametes after 1 breeding cycle. Okay, so to show the expected number that did not produce and did produce after 1 breeding cycle. So the first thing that we need to do is work out the proportion, because if we look at the null hypothesis references the proportion of plants. So first we need to work out what proportion of plants produce 2N gametes in our expected table. Okay, so we've got 50 that did not produce 4N gametes. So we've got 50, I'll just do it over here, 50 did not produce 4N gametes and 4 did produce 4N gametes. Okay, so they did not and they did. Okay, so this is from our expected. So we need to find out the proportion of either did not or did in our expected group. Okay, so what proportion? Let's focus on the ones that did. Okay, so what proportion did produce 4N? So the first thing we've got to do is we've got to get our total number of plants. Our total number of plants is 54. What proportion of 54 did produce 4N? The proportion of 54 that did produce 4N is 4 divided by 54, which is 0.074. So approximately 7.4% of these plants did produce 4N gametes. Okay, so if we go back to the question, so looking at the question, we're looking at breeding cycle number 1. So breeding cycle number 1, in the observed column, it tells us that 14 plants did not produce and that 42 plants did produce. So we want to know what the expected values for that breeding cycle should have been. Okay, so in order to do that, we first need to know the total number of plants that were used in the investigation, because the investigation is the observed. So we've got 14 plus 42. 14 plus 42 is equal to 56. So they used 56 plants to get the observed value. So what did we actually expect? So that's what we observed. What did we actually expect? Well, we expect this ratio of plants, this proportion of plants, to not produce 2N. So if we're going to not produce 4N, sorry. So if we want to know what number of the 56 plants did not produce 4N gametes, we multiply by 56 by 0.074. And when we do that, we get a number of 4.1 something. The question says round it up, so we can say that it is actually, it is 4. Okay, we can say that there are 4 out of 56 did not produce, 4 out of 56 did not produce, okay, 4N gametes. Okay, so they did not produce 4N gametes. But we've got 56 plants. If 4 of them did not produce 4 gametes, then we expect that 52 should. Okay, so if we go back to our table, we would work out that we expect 52 not to produce, sorry, it's 2 gametes, sorry, it's 2 gametes. 52 to not produce 2 gametes, and 4 that should produce 2 gametes. Okay, so that's what we would expect, right? Okay, quite different to what we actually observe. You can see the observed values are quite different to the expected values. All right, so let's go on to the next part of the question. So next part of the question I've put over here. The proportion of plants that produce it. Okay, we've done that. All right, so I've put this here because I wanted us to just be aware of the null hypothesis. Okay, so the null hypothesis. When we write a null hypothesis, that's the null hypothesis H0. Okay, and the null hypothesis always says that there is no difference. So there'll be no difference between the expected and observed values. So in the question it says the scientists tested their null hypothesis. So there it is. They test this null hypothesis. The proportion of plants that produce 2 gametes will not change from one breeding cycle to next using chi-squared statistical test. After one cycle, they calculated chi-squared value was 350. So when they did that chi-squared test, if you remember, we did a couple of them, they ended up with a value of chi is equal to 350. And if you remember, what we do with this is we go to our chi-squared tables. So up on the camera, you should see chi-squared tables. So we'll go to those in a second. So you calculate a value, and then in the table you go to the column where p is equal to 0.05. Okay, p is equal to 0.05. And what that means is that if your value is less than p is equal to 0.05, if it's less than that, then there is a less than 5% probability that the difference between the expected and observed is due to chance. All right, so let's have a quick look at this table. All right, so this is in your book. This is page 580 in your book. Okay, and we are looking at p equals 0.05, and this investigation has got 1 degree of freedom, and it tells us, it tells us that the critical value is 3.84. Okay, 3.84. We've been told that the calculated value is 350. And so if we had to try and place 350 on this table, we can see that the numbers are getting bigger going in that direction, getting smaller going in that direction. So 350 would be way off here somewhere, okay? So that means that there is a very low probability, there's a very, very low probability that the difference between the results is due to chance. Very, very low probability, because that value is sitting along here, probably less than 0.001. Okay, so the rule that you just need to remember is that if the calculated value is less than the critical value, then the probability that the difference between the results is due to chance is very, very small. Okay, so that's what you really need to try and remember. And there are various, there is a PowerPoint available to you that will help you with this and help you hopefully write a good answer. So let's just go to that PowerPoint really quickly. So not that slide, this is the PowerPoint. It's called Statistics Stock Sentences, okay? And you'll find that in the statistics section of the team. And it's all about how to write a good sentence. I'm not going to take you through the whole PowerPoint because you can spend some time looking at it. It explains to you why we talk about difference. You don't just say the results, you always talk about the difference between the results. A little bit about null hypothesis, what p-value actually means. And if you have a look over here, it's telling you that, I'm just going to draw on here quickly. So if you have over here, if p is small, so this is what we're looking at the moment, if p is small, then there is a low probability that the difference between the values is due to chance. In that case, we do not accept the null hypothesis. And here we have it, what we were just talking about, the calculated value of t would be greater than the critical value. So what we've just seen is the calculated value, well, in our case, it's chi, okay, because it applies to chi as well. Calculated value of chi greater than the critical value in the table, and that critical value was 3.8, okay? So when we have a situation where the calculated value is greater than the critical value, then we know that p is less than 0.05. Okay, all right. So what to write? So these are the stock sentences that I want you really learning. Okay, so this is for if p is greater than 0.05. This is if p is less than 0.05, which it is in this particular example. Then what we write is the probability of the difference between the two values being due to chance is less than 5%, okay? It's really important that you get all of these words in: probability, difference, and chance, okay? And in that case, we tend to reject or not accept the null hypothesis, okay? So let's think of a good answer that we can write for this. We could say, okay, so the scientists tested their null hypothesis. What does this result suggest about the difference between the observed and expected results? Okay, so we could start off by saying the calculated value is greater than the critical value. So that's the first thing that we can say, all right? And then we could say that this means that the probability between the expected and observed values being due to chance is less than, you could say less than 5%, or you could say less than 0.05. Or if you say less than 5%, that's absolutely fine, okay? So what does it mean? So it says here, what does this result suggest? So that's what the result suggests. It suggests that the probability between the expected and observed values being due to chance is less than 0.05%, okay? And what can they conclude? Well, let's go back, because we've been given a null hypothesis over here. We've got a nice null hypothesis. What can they conclude about that null hypothesis? The null hypothesis says that there is no difference. So we can say the scientists do not accept the null hypothesis. Okay, right. So that, to me, seems like a credible answer. If we have a look at the mark scheme for this, let's scroll down. Let's scroll down and see what they say. And they say, oh yeah, there is less than a 0.05% underlying probability, okay? Less than a 0.05 probability that the difference between the observed and expected occurred by chance. Calculated value is greater than critical value, so the null hypothesis can be rejected. And then the scientists conclude that the proportion of plants that produce 2N gametes does not change from one breeding cycle to the next. So that's what I didn't spell out, so that's what you should. What did they conclude? The proportion of 2N gametes does change. It significantly changes, does change from one breeding cycle to the next. But if we just look at these underlined words, probability, difference, and chance, and we look at the answer that we gave earlier on, and we said here, means that the probability between the expected and observed values being due to chance, the probability, look what I left out. I left out difference. The probability that the difference, so I might not even got that mark, the difference between the expected and observed values being due to chance. Okay, I did it there, forgot to do that. All right, so just emphasizing, they're quite difficult sentences to get right, but if you can learn them from the PowerPoint, all you need to do is recognize whether or not your p-value is less than or greater than 0.05, and then you just apply the sentence accordingly. Okay, good luck with that then.